Alright, you guys, welcome back to the Magnetic IDEX channel. This is an unplanned video, so let me just jump in really quickly and show you a couple of updates and talk about where we're at. These little Picolino gears are going fast, so check them out on my Ko-Fi shop. I have about 20 pieces left. Why this video? So I was gearing up for a race between X2D and Picolino with a Cooler 3 motion system, and lo and behold, got a small hiccup. The zero gravity coupling has given up the ghost, and I super glued it on so you can see where it failed. This is my little zero gravity, and I'm missing some material here. I don't even know where it went. Surprisingly, the machine kept printing because I still had a square here, so it was chugging along even though it was completely detached from the zero gravity coupling. One of my previous design iterations was a removable pulley that I could just press in here and lock it with set screws. The only catch is I didn't have a way to put this on a bearing, so that means that this pulley would have been completely supported by this piece and fully cantilevered, and I wouldn't have a bearing surface on this side while I had a bearing here. This needed an adapter and just didn't feel right, so I abandoned this option early on. One of the ways of fixing it was to do a larger pulley that would still be 3D printed. And so I was looking at, the original pulley was like this, 21 teeth, and I thought maybe I should go to a 26 tooth pulley, still GT 1.5. like so, but check this out. One of the concepts that I had was to actually do a vase mode print of the pulley and then do an offset print on the main body so that I can quickly and easily assemble it and have really fantastic quality. This one is actually printed with a 0.2 millimeter nozzle, so check this out. I have this sleeve that is that can be bonded to have a really decent focus here, that can be bonded to the main pulley. So this is a way of achieving a perfect flawless wall quality without sacrificing your print time and without other problems such as seams. So I really like this concept. I think I'm going to apply it to other gears as well, and just look at how I can bond the sleeve. So spur gears, helical gears, all of the concept can apply really well, and then you have nearly flawless finish. No random seams, no zits, nothing on the surface, on the gear surface. So really interesting solution. And I bet if I was to use rubber cement, some gears might actually enjoy a little bit of damping, but perhaps just super glue the two together. It's not as critical for pulleys because you have really large contact surface with the belt, so I don't think it even needs to be glued here. But for a spur gear, absolutely, we need to figure out a way to bond the sleeve. So I thought that was a really neat solution. But for now, I might apply this only to the idler side. So let's see what I'm doing with the main zero gravity coupling. So instead of kind of going back to my original idea of pressing in an existing pulley, I decided to take this apart and then find a way to keep it from requiring any additional machining or turning. So I wanted to make this as DIY as possible. So now I'm simply pressing this in. I have to be very careful to maintain concentricity here, but this shoulder here will be running on a 10 millimeter ball bearing, a 10 millimeter ID, like so. I'm not gonna press it in here. It's gonna be a little bit of doing, but that's the idea here. And then a 10 millimeter bearing will press in on this side. And so this is my zero gravity coupling. Now let me show you how easy it is to dismantle these pulleys. They seem like pretty bulletproof assembly when you get it. And so I decided to make a small little disassembly jig. So basically I have a little piece here, so I can press the flange off and then flip the gear pulley and press off this piece. So first you have to remove all of the set screws because they go through both the collar and the main part. So let me do this on camera, see if that helps anybody. So I have this little anvil or jig, and then I have everything's printed in PLA. So let's see if we can capture this on camera. Let's get my trusty little persuader tool, and I'm sure I lost something. So that came off extremely fast and easy. And let's flip this like so. Put our tool on here and try to rotate in such a way that you can see the disassembly process. One more tap. I lied, 2 more taps, and the pulley is fully disassembled. So now, I hope I got a decent focus on that, because that would be a shame. Now I can use this on my zero gravity coupling. So that's one concept here that I wanted to share. On the zero gravity here on this adapter, I do have teeth, but they start only about halfway. So again, I have a very nice lead in that I press in that just goes on the OD, and then I find the teeth, and then I need to make a jig to press this perfectly. Maybe even use a threaded rod and just pull it perfectly concentric. So something I still have to work out. But the really nice thing is the coupling is rolling extremely well. It's sliding perfectly, no backlash. So this is going to be my zero gravity. Now, one interesting side effect here. By increasing this tooth pulley to 26 teeth, so I'm going up from 21 to 26, I'm also changing a reduction on my first stage or on my motor belt to coupling that drives the square shaft. And there I'm able to cancel out the fact that this is a larger pulley. So in Clipper, my rotation distance remains virtually the same as if this is the original 21 tooth pulley. So that's kind of nice. My zero gravity coupling will be spinning about 20% slower while maintaining the same print speed per motor rotation. So my rotation distance is virtually unchanged. It's a fraction of a millimeter, I think it went. I'll put the numbers on the screen for the rotation distance, but this is going to be fantastic. So I'm modifying all these parts, putting in all the improvements that I've wanted to implement here. This is a previous iteration. I've got one more print to do, and reprint some of these parts, and we'll be in business again. But Yeah, I was surprised how well it kept printing even without being attached to the zero gravity coupling. And then that caused all sorts of failures, print failures on my zero gravity or on my speedboat race. Now, Dimitri, you may be asking, why are you joining the dark side? Why are you buying the X2D? Well, I used my Maker World points, and so I got the printer for about 500 bucks. And this is the reason why I got it. I really wanted to try out the vision encoder and to see how that would work. So that's one of the two main reasons I purchased that machine. I figured I can always convert it to a clipper machine and install a Picolino extruder later. But for now, I wanted the vision encoder and the heated chamber. So that's why I went with the X2D for now. I know there's a lot of bad press going on with Bamboo right now, and well-deserved bad press, but I need to know my enemies. So that's why I purchased that machine. Sorry about that. What else am I forgetting to mention? Oh, and I did update my printables to include the 26 tooth pulley alongside with the 21 tooth. If you're working on a printer that you would like to try out GT 1.5 pulleys, there are not very many CAD models available, so 21 and 26 tooth step files are available on Printables, so check this out. If all goes well in the next video, you should be able to see side-by-side race with Picolino extruder versus X2D. So I'm really excited about that. But before that, I have to make some of these fixes. As always, thank you to all of my Ko-fi supporters. You guys are awesome. Leave in the comments if you have already received your gear and what you're planning to do with it next. Like, share, subscribe. Bye.